Hey guys, welcome back to STR8CHEM. In this video, we're going to learn on problem solving in Emission Spectra Part 2. Problem number 1, how many electronic transitions are possible? Okay, how many electronic transitions? That means how many electron transitions from higher n to lower n between the first 4 energy levels. So we have 1, 2, 3, 4. So those are the first 4. 1, 2, 3, 4 of hydrogen atom, and that should be the one that we want to look at is in Balmer series. So the key points over here is electronic transitions, the first 4 energy levels in Balmer series. Okay, electronic transitions means the movement of electrons from top, okay, in this case from higher n to lower n. So that is what it meant by electronic transitions. The electron moves from higher n to lower n. It can be from lower n to higher n, but then again, you need to remember over here, you want to know for Balmer series. So Balmer series only will exist when the electrons moves from top to bottom. Okay, so you need to remember that. Electronic transition refers to the movement of electrons from higher n to lower n, or lower n to higher n. But you need to remember over here it says about Balmer series. So Balmer series, like I said just now, will only going to be able to exist when the electrons move from higher n to lower n. Now, we need to consider the first 4 energy levels. 1, 2, 3, 4, okay? And the question is only once for Balmer series. Therefore, the answer is 2 electronic transitions. Why? Because for the first 4, you will, okay, we only going to look at the first 4 energy levels, yeah? 1, 2, 3, 4. So this is going to be the topmost and energy level for this particular question. So you can have the first one from 4 and drop to and 2. So this is the first one. Okay. You can have this transition, or also you can have this transition. Right here. Okay. You can have 4 going down to 2 and 3 going down to n to 2. Why do we not consider the one 4 to 1 and 3 to 1? Okay, so that's a very good question if you're asking that. The reason is because, again, I would like to remind you that question wanted to be in Balmer series. And we have to recall that in Balmer series, the n final is equals to 2. Okay, recall the L, B, P, B, P. Okay, so you have 1, 2, 3, 4, 5. So Balmer, the n final will be n equals to 2, the n final. Okay, so let's have a look at another one. in the atomic emission spectrum of hydrogen, how many lines? Okay, so here it's kind of if you compare this question with what we have here, it doesn't say about lines in problem number one. So the only thing that will give you the idea that lines will be produced is when the question mentioned about Balmer series. In problem number two, it doesn't say in which series. Is it going to be in Passion, um, Balmer, or Lyman? It doesn't say. But we do know that this is going to be talking about the transition of electrons from top to bottom. Why? Because it says how many lines. And the lines in emission, in atomic emission spectrum, will only going to be produced when electrons are moving from higher end to lower end. That's when you get the line spectrum. If the electrons are moving from lower end to higher end, line spectrums are not forming yet, okay? Because photon has yet to be released. You need to remember that. Now, this question or problem is similar to what we have done in the first one over here, but with less restriction. What we have is the first 5 energy levels. So they want you to write the transition of electrons. So that is the same as electronic transition, okay? So I just want to point that out. So this is the same as electronic transition. And the answer is going to be 10 transitions of electrons. So we need to consider the first 5 energy levels. 1, 2, 3, 4, 5. 1, 2, 3, 4, and 5. Okay, so we can have transition. We can take from the lowest one first, from N2 to N1. Okay, we can have this 1, and then we have 2, 3, and 4. Okay, so we have 1, 2, 3, 4. Also, we can have 1, 2, 3, and 1 and 2, and finally this right here. So how many is that? So if you count that out, you have 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So we have 10 transitions of electrons between between the first 5 energy levels, okay, in the atomic emission spectrum of hydrogen. So this is how you can answer this kind of questions. You have to have this diagram uh, drawn for you, and then you can try to do the transitions to look for how many transitions will be produced. Right, so problem number 3. Explain why each successive line becomes closer to the previous one until the lines converge to form a continuous spectrum. So why is this line spectrum over here? So this is your line spectrum. Why are the lines are getting closer and closer and closer and forming the convergence limits? Okay, successive lines. So this is the successive lines, line after line after line. And it's become closer and closer and closer. Why? The reason is because number one is the spectral lines. Okay, so the lines over here converging because the difference in energy, because the delta E, the difference in energy between successive energy levels. So we are talking about these energy levels over here. So the delta E is becoming smaller and smaller. As you can see, when you are comparing N2 to N1, N3 to N1, and so on, so it's becoming smaller and smaller and smaller. Okay, so that is the key point over here. Difference in energy between successive energy levels. Okay, between successive energy levels, the difference in energy becomes smaller. Successive means energy levels after energy levels. And then point number two, the distance of the orbits energy levels. So these are the orbits. The distance of these energy levels are going to be further and further away from the nucleus. So the nucleus, you can imagine the nucleus is going to be right over here, the closest to n equals to 1. So the energy level will be coming further and further and further away from the nucleus, and that's another reason why the difference in energy between the successive energy levels is becoming smaller. So this is the standard answer for this question if you get it in exams, okay? Now, problem number 4. You are given a table over here with the color of line spectrum. You have red, green, and blue. Given over here is the wavelength, okay? So number 1, you need to calculate the energy emitted in the formation of red line and green line. So A. So how do you do that, A? So for red line, again, we want to find the energy. You can use this formula over here. Delta E equals to Planck's constant times the frequency, or hc over lambda. And then when you put the equations, okay, I'm just gonna do, so when you divide that like so, you should be able to get your answer as such, okay? So what happened over here is, so I'm just gonna try to make this, okay? So what happened over here, you're just gonna plug in the values inside the formula, and then you would be able to get the energy for the red line. So this is in joule, so you can convert that into kilojoule. It's really up to you. Second, to find the energy for the green line, so we're going to use the same strategy. So you're going to divide that. Okay, so you're going to, this is the Planck's constant, speed of light, and need to remember, you need to times 486.3, change that nanometer. Nano, remember, nano is 10 to the power of negative 9 meter. Then you get your energy. Okay, so I think this is quite easy because we have talked about this before. So in exams, they're going to give you 1 mark for this one, 1 mark, 1 mark, and 1 mark. So that is for A. What about B? B, it says that you need to sketch the energy level diagram to show the transitions of electrons that produce red, green, and blue lines. So how do you do this in exams? So you need to, first of all, draw the energy level diagram. So the energy level diagram that you need to be able to draw is like this. Okay, so this is how you're going to draw the energy level diagrams. The energy levels will be coming closer and closer and closer to one another until you're going to have the n equals to infinity. So you need to label your energy levels and label n1, 2, 3, 4, and so on. Okay, so this is the energy level. And then the question wants you to show the transition. So how do you do that? So this is the answer. This is for red line. This is for the green line. And this is for the blue line. Of course, in exams, you do not have colored pens. So what you can do is you can label. So this is for the red line. This is for the green line. This is for the blue line over here. Okay, you can just label it like that. So when you do like this, you would be able to get 1 mark for correct energy level diagram. Okay, and then 1 mark for this red line, 1 mark for the green line, and 1 mark for the blue line. The transition must be correct. Now the question is, how do I know that red line will be 3 to 2, green line 4 to 2, and blue line 5 to 2? So how do you do that? Do you memorize this? No, you don't have to. You don't have to memorize this. What you can do is, I'm going to show you one examples on how do I get the transition for red line. So since the lines have colors, we know that it will be in Palma series. The question doesn't say in which series. It doesn't say whether it's going to be in Lyman series, Palma series, Passion brackets, or Fun. But the clue over here lies in the table. Okay, it says you have red, green, blue. Among all of the series, okay, this is visible, okay, because you have colors, so it is visible. So for the visible region, that one is for Balmer series. So Balmer series is the only series falls in the visible region. Okay, we have visible region, we have ultraviolet region, and we have infrared region. Remember that, guys. You have been explaining about it in the at puzzle video. You can go back to that video. Okay. So Balmer series, this is visible. You have colors. You can see it. You know that the color will be red, green, and blue. So that is another skill that you need to learn from this. So since the lines have colors, okay, have colors. Why? Because it's in the visible region. So you have Balmer series. So when you have Balmer series, we know that end final will be 2. Okay, the end final will be 2. The electrons will fall to n equals to 2. Now, I'm just going to show you for red line. So I'm going to use this formula here, this calculation by using Rydberg equation. I have 1 over wavelength. So this is the wavelength of the red line just now, equals to the constant. And I have 2 because n final for Balmer series is 2. And the only thing I need to find is this, n initial. I want to find what is the n initial. So when you do this mathematically, it's a very simple mathematical calculation right now. You solve this, you get this to the other side, 1 over 4, 2 to the power of 2 is 4, you get 0.25, then you get in this form. So you solve this, and then you get this to the other side, you would be getting something like this, yes? You get negative 0.1111 equals to negative 1 over n initial squared. So when you get negative 1 to negative 0.1111 to the other sides, and this one to the other side, you get n initial square 9.0009. So this is essentially 9. So square root of 9 will be 3. So now we get the information that n initial will be 3 and n final is 2. So that's why your red line is from n equals to 3, n equals to 2. So the same technique can be applied when you want to find for green and you want to find for blue. So I'm going to leave that for you guys to try. So try for blue line and green line by using these equations over here, and you should be able to get the answer for this transition. Oops. For the transition just now, okay?